In this video, I'll be going over a few examples of how to design parts in Solid Edge that will make it easier to assemble when 3D printing them. This will include a dovetail joint, using Solid Edge's lip function to create covers and lids, and using hexagon cutouts for easy assembly using nuts and bolts. So here I'm going to show you how to quickly make a lid for this electronics enclosure. I'm going to go ahead and add a body and name it lid. Then I'm going to create an extrusion and I'm going to use a parallel plane and I'm going to put it 2.5 millimeters below that face I selected. That's going to be the part that's inside the enclosure, holding it closed. So here I'm going to use the project to sketch command and select the inner profile of the base. I'm going to extrude that up by 5.5 millimeters. So you see I have this extra space around the edge there. So to fill that in now, I'm just going to create a lip. You can do the use the lip command here, select the edge, and that's the profile I'm going to add around. Width of 3 millimeters, height of 2, and click to finish. And there you go. It's as easy as that. I've now created a lid for my electronics enclosure. So in this example, we have a case here, sort of like an enclosure, and we want to create a cover for this that's going to create a full seal and stay closed. So we want to cover something like this, and a quick and easy way to do this when 3D printing is to add a lip. So in this example, we're going to add a lip along this edge where we're going to add material. So I'm going to put the profile above the body, so it's going to add material there. And then we're going to basically do the same thing on the cover, but the opposite. Now we're going to remove material. So I'm going to make it my active body, select the edge, and this time the profile is going to be into the body. So this means it's going to remove material. So now you can see I have a nice snug fit there. It's going to be a press fit. You can put some glue along the inside edge of the lip, and that'll create a nice seal. So here I'll be showing you guys how to assemble these two parts if we were to 3D print them using a dovetail joint. So starting off with the first part here, I'm going to create the protrusion. And I'm going to be following HP Printer's general guidelines when creating these. It doesn't have to be exact, but they give you some general guidelines just to ensure a nice snug fit. So that's the general shape that we're going to use. I'm going to extrude it to the end of the plate there. Now we're going to add some rounds to each of these corners using a 0.5 millimeter radius. Now this is done. We're going to go ahead and mirror this about the center plane there. Make sure you select the round and the protrusion feature. And that's done. So now we'll go and make the design body to the active body. And we're going to use the subtract command here. And select it as our target body and the other design body as the tool body. And it's going to create that, it's going to subtract the material for us, nice and easy. Okay, now we just need to offset these faces a bit to give enough clearance so that they fit. We can use the offset faces command. We'll take the entire chain, offset it by 0.2 millimeters. And then we're going to change this option to face and select these two faces here and we're going to offset it back down to 0.1 millimeters. So this is following HP's guidelines again. These two faces should be offsetted only by 0.1, where the other should be 0.2. So you see we have the clearance there, and that's how you would create a dovetail joint assembly for 3D printed parts. Okay, so here we have two parts, and let's say we want to 3D print these two parts separately, and for whatever reason we may have a variation of the green part there named the plate. There might be longer or shorter pieces, so we need to find a way to assemble these parts together. So here we have an example using a nut and a bolt, and as you can see, the nut is going to be embedded into the plate. So we're going to have a cutout in the plate to kind of hold that nut secure, and we can just screw in the bolt easily. So we'll start off by creating some clearance holes here for the bolt. I'm using an M8 bolt, so I'm using cutouts with a diameter of 9 to leave enough clearance for those bolts. As you can see here, I'm leaving just a bit of clearance. I'm going to head to create those cutouts using the through next. It's going to go through the part. And you can see the holes have been created there. So now we'll be doing the same thing for the plate. And I'm just going to use the project to sketch. So it'll be linked if these holes move on the bracket. It's going to follow suit on the plate as well. And again, through next. So now you can see I have my clearance holes for the bolt on both of the parts. And just to verify that I have enough clearance there, that looks good. Now I want to create the little cutouts for the nuts to be placed inside here. So these nuts I'm using is M8, and they use a diameter of 13 millimeters. So when I go ahead and create my hexagon, I want to use a diameter of 13.5 just to leave enough clearance to make sure that nut fits nicely in there. I'm going to enter in 6.75 as the radius, which is going to give me 13.5 millimeters as the diameter. The diameter is what the profile uses to create the hexagon. As you can see there, each midpoint of the lines are connected to the diameter. And then I'm just going to add a constraint to align that midpoint up to the middle so those lines won't rotate. You can see both of the black profiles now, they're both fully constrained. And now I'm going to use a depth of 6 millimeters. I believe the nut is 5 millimeters or 5.5. Just want to leave a bit of clearance there. And you can see that's what it's going to look like. So the nut is going to sit inside there. And let's make sure I have enough clearance there, which looks good. You don't want to give too much clearance, then it'll wiggle around. So that's it. There you have it. There's a quick and easy way to assemble 3D printed parts using a nut and a bolt, and using the embedded nut there. Just it's a bit more convenient than having the nut extruded outside and then you have to hold the nut while you're screwing the bolt. So that saves that extra step. And here you can see me saving the STLs one by one, and then I would go ahead and show the plate body and then save this one as an STL by itself as well, and then I can send them off for printing.